Hi, this is Neil Kumar from Import Classes. In this brief video, I will be discussing the use of statistics with data mining for advanced business analytics. It's important to note that this is actually a three-part series. So in this video, I will actually go into descriptive statistics. In part two, I will discuss inferential statistics. And actually part three deviates from stats, and we actually discuss something called database querying. And the reason why we're actually putting this three-part video series together is because much of the focus of our video series so far has been on data mining and data science, but in reality, there are other techniques that business people use to solve business problems as well. And so we figured it would be interesting to share insight into these other techniques. It's also important to note that these techniques should be used together with data mining. It's not that one is better than the other. You should really think of statistics, database querying, and data mining as tools in a toolbox. And depending on the problem that you have at hand. So for example, if I need to unscrew a screw, I'm going to use a screwdriver, not a hammer. Or if I need to hammer in a nail, I'll use a hammer or perhaps something else. But the point is, each individual problem has a specific tool that we can use to fix it. And that's the same application in the business world. So some of these problems could be pretty large, and when you break them down into subproblems, different analytical techniques can be used to solve those different subtasks. So point is, you use the techniques in combination with one another to solve complex business problems. Anyway, getting back to statistics, what I want to discuss are first the two broad meanings of statistics. The first one refers to data, and what that really means is a value. So it could be number of feet, revenues, growth rates, costs, percentages, number of clicks on a website, et cetera, et cetera. And the second meaning refers to methods. And from a statistical standpoint, there are actually two different types of methods. We have the descriptive statistics, also known as summary statistics, and a second method called inferential statistics. In this video, as I said, we're going to focus on the first one, descriptive statistics, and in the second video, I'll focus on inferential. So descriptive statistics is all about how data can be effectively summarized to describe important aspects of larger data sets. And typically, the data is turned into information by amassing all of these numerical details into a cohesive picture. And typical descriptive stats include summations, averages, medians, modes, rates, percentages, etc. And the different statistics that are chosen for an analysis should be chosen with a certain level of attention to detail to the specific business problem that we're analyzing, as well as to the distribution of data. So what do I mean by distribution of data? Well, you may remember from stats class back in high school or college that not all data is what we call normally distributed. So the whole bell curve distribution of data is what we call normal, and not all data that we come across fits that bell curve distribution. You know, we could have something called positively skewed data, negatively skewed data, or something even called kurtosis, which means that a lot of the values are centered around the mean. So the top part of the bell curve is a little bit more peaked or less peaked than usual. And so regarding the descriptive statistics, let's call it technique, the problem-solving process for summary statistical analysis really has three parts. The first one is, have you thought about the exact question that you want to answer? The second part is, have you analyzed the data distribution? So for example, is it normal? Is it positively skewed? Is there kurtosis? And number three, is the chosen statistic that you're analyzing in the data appropriate? So for example, using mean may not be appropriate for a specific type of distribution. Again, because a lot of these different techniques assume normal distribution, you can't always assume that given the data that you have. Now, to kind of drive this point home, what I want to do is illustrate examples of questions that you can answer using descriptive statistics. So the first one is, what is the average unemployment rate in China over the last 2 years? That's a simple descriptive stats problem. Or number two, what was the most frequent score on a math exam that you gave last week? Or number 3, at what percent return is a certain hedge fund considered a bottom quartile player? Although this very last question is a little bit tricky. And for those who are finance people watching this video, you know that hedge fund returns are actually negatively skewed and they have substantial kurtosis. So you can't simply plot this again using normal distribution and looking at Z tables and T tables to figure out what that bottom quartile value is. You have to use different statistical methods. So the very last thing I want to mention is that stats alone are okay, but even more powerful are when you combine statistics together, or you combine statistics with values to create something called ratios. And ratios obviously have a numerator and a denominator. And it's really important for you to recognize that ratios are only meaningful when the numerator and denominator make logical sense together, number 1. And number 2, the numerator and denominator need to make sense from a time standpoint. So for example, if my numerator is over a period of time, while my denominator is at a specific point in time, that would be considered a nonsensical ratio. Or maybe nonsensical is a little harsh. It would not be considered the best kind of ratio to analyze. Anyway, I hope you enjoyed this brief video on descriptive statistics and how it can be used with data mining. And please stay tuned for part 2 of this video series, as well as additional videos that we will be creating. Many thanks, and have a great one.